morning, everyone. Today, thank you for being here. Today, I will present our study on Pakistan's temperature trends, focusing on predicted changes in 2025 and their connection to global warming. This project has been made by Amna Mehboob, and my teammate Laiba Hamid. We combine historical data, predictive modeling, and global research to identify patterns and explore their implications for climate change. I'll briefly walk you through what we're going to see in this presentation. We will first dive deeper into project's background, into our project's objective, solution, process, and finally our findings as well as our resources. Our project centers on analyzing temperature variations from 2023 to 2025 for major Pakistani cities. We focus on three key objectives: understanding factors influencing temperature changes such as pressure, precipitation, then determining seasonal and station-based temperature trends. Finally, predicting 2025 temperatures and comparing them to previous years. Through this analysis, we aim to link these findings to global warming and its potential impacts. To address our research questions, we analyzed the relationships between atmospheric factors like pressure and temperature, seasonal trends, and station specific temperature ranges, the extent of temperature variation between 2025 and prior years. Each objective helps us piece together the climate story of Pakistan and assess its broader implications. We adopted a structured approach using the data science life cycle. Our goal definition was to determine the goals around examining temperature trends and predicting future values. We finalized the data by using data mining techniques from our resource to create a data set that looked at 25 stations, analyzing attributes like mean temperature, pressure, and precipitation. We did data cleaning to ensure consistency and accuracy, exploratory data analysis to reveal the trends such as seasonal highs in temperatures during summers. Predictive modeling. We used linear regression to predict 2025's temperature. We did some comparison analysis to compare the findings with historical and predicted data to validate the trends. Our findings reveal the following: vapor and station pressure are directly proportional to temperature, suggesting that as atmospheric pressure increases, so does the temperature. Conversely, sea level pressure demonstrated an inverse relationship. Precipitation, however, showed no proportionality. For instance, Rawalpindi experienced high precipitation but also higher than expected temperatures. To further illustrate this, consider Karachi, where vapor pressure averaged 24.8 MB and correlated with a mean temperature of 28 Celsius.
Our findings 2024 to 23 year maximum temperature trends. So we find out that the maximum temperature range is from 36 Celsius to 22 Celsius. And the station with the lowest maximum temperature is Panachina, recorded 22.6 Celsius, while the station with the highest maximum temperature is Shah Nazirabad with the temperature of 36.3 Celsius. Major cities like Karachi, Rawalpindi, and Peshawar recorded between 32.2 Celsius to 30.9 Celsius. Okay. Our findings 2024 to 23 year minimum temperature trends. So we found out that the temperature minimum temperature range is from 8 to 25 Celsius, and the station with the lowest minimum temperature is Panachinar with a temperature of 9.2 Celsius, while station with the highest minimum temperature is Karachi with the temperature of 23.5 Celsius. And major cities like Karachi, Rawalpindi, it is range from 23.5 Celsius to 19.7 Celsius. So this is about seasonal temperature trends for the year 2024 to 2023. And okay, This is for analysis of season temperature trends. In autumn, we have seen that the temperature range is from 25 to 12 Celsius, and the highest temperature is Bay Nazirabad with the temperature of 39.3 Celsius, and lowest temperature is Panachinar with a temperature of 12.1 Celsius. And in spring, it's ranging from 20 to 7 Celsius. Highest temperature station is Shah Nazirabad with a maximum temperature of 39.4 Celsius, while the lowest temperature is Panachinar with a temperature of 7.4 Celsius. In summer, it's ranging from 17 to 29 Celsius, and the highest temperature is in summer is Nukhandi with the maximum temperature of 43.6 Celsius, and the lowest temperature of station is Panachinar with a minimum temperature of 17.3 Celsius. In winter, it's ranging from -1 to 12 Celsius. Highest temperature is Chor with the temperature of 28.5 Celsius, and lowest temperature of station is Panachinar with the minimum temperature of -1.1 Celsius.
Our predictive model reveals the mean temperature a rise of 0.51 Celsius compared to 2024 to 2023, with an average of 25.13 Celsius for 2025. The maximum temperature has a slight decrease of 0.6 Celsius, reflecting stabilizing summer extremes. Minimum temperature an increase of 0.44 Celsius, indicating warmer winters. Parachinar, historically one of the coldest stations, shows significant warming trends, with winter minimums approaching 0 Celsius from a baseline of -1 Celsius. These findings align with global patterns of reduced temperature variability in response to climate change. Let's connect our findings to broader climate research. Rising mean temperatures, consistent with Lopez et al., our results show steady warming, which impacts agriculture and water resources. Sea pressure relationships. Peters' research paper linked rising sea levels to reduced atmospheric pressure and warming, mirroring patterns in Karachi. South Asia's, vulnerab- South Asia's vulnerability. Shah's research paper highlighted South Asia's dependency on monsoons and agriculture. Our study supports this as temperature increases and unpredictability precipitation threatens these systems. Warmer winters in northern stations like Peshawar and Islamabad challenge traditional crop cycles, emphasizing the need for adaptive agricultural practices. Finally, you can see our resources. We took our dataset from the Pakistan Meteorological Department Climate Data Pre-Processing Center. Then you can see the 3 research papers that we consulted to further analyze our findings. Here you can see Peter's research paper, Sea Pressure and Regional Climate Variability, Shah, Shah's Climate Dynamics in South Asia, Lopez Regional Climate Modeling for Global South, and a link to our project. We're going to briefly walk you through our working. So first we imported the necessary libraries. We read the file. Then we looked at the basic columns within our dataset. Then we did our first objective, which was looking at how the factors affect the temperature. Then we did some data cleaning and we did some data analysis on the mean maximum temperature, mean minimum temperature, the seasonal trends. Finally, we applied linear regression to predict 2025's temperature. And we wrote down our findings within the notebook itself. Thank you.